Hello guys and welcome back. So now we're going to start looking at the real example and we're going to destroy this geometry. Now I've done destruction of the this part, the back block, and we're going to do this front block and everything is exactly the same, so the techniques are going to be pretty much the same. And this environment is built of modular components, and these are the main parts of it. And if I copy this, this is how it's built basically. And what I'm going to do is the reason I started with this is I want to fracture only one of them and then duplicate that over and over. I don't want to make unique geometry and waste a lot of computation. And to make it fast enough, I'm gonna just focus on one block and work with that, and then once I'm happy with the result, I'm gonna add the other groups. Even for the final result, I tried to, I think I had three copies, and the entire environment was, I think, at 15. Actually, let's do this. Let's mirror. And this is not the final environment. This is something that we've created in the Introduction to Houdini for 3D Artist workshop. I went ahead and optimized the geometry so it's ready for destruction, and I've made sure that there is not so much penetration, there's no crazy geometry or anything like that. But the final model had a lot more detail, so I wanted to make it lighter. So this is how the environment is assembled basically, and we're just going to focus on the first block, this guy, and then set up the entire destruction. So let's do this. What I've done is I've grouped each one of these guys into a separate group, so I'm gonna isolate them, and let's just make a copy of all of this and do it separately. So this is the arc. Arch interior. Cool. And depends on how complex your geometry is, you need to do this preparation as well, and you want to separate the pieces so we can fracture them individually and work with them. You can obviously deal with it all at once, but I want to do some high-res workflows for creating interesting details. I want to fracture these pieces separately from the rest and treat them differently. Cool, so these are the main blocks, and I'm going to start by creating a VDB from Polygon. Cool, and let's gather some points. And Voronoi fracture. Now, the more complex the geometry you have, the slower it's going to be, obviously. Cool, so this one is pretty simple, so you can see it went through it quickly, but for some of these guys it's going to take longer. Now, one thing that we can do, people complain about the Voronoi look. I actually think it's a very realistic look, especially if we add edge details and displacement and stuff like that. But what we can do also, we can add, we can make more interesting points. So I'm going to copy this and set it to 10 points. I'm going to use a point replicate node. And this is going to create copy points around those points. And I'm going to change it to sphere. And let's increase the radius. And let's add some noise. It has a cool feature. So let's add some noise there. Probably too much. Just 10 points. And then we have a different set of points. And you can use your imagination to create any Cool. And then we have more randomized points, which we'll see, like, for example, this part here. We're getting these small pieces and big blocks, small pieces and big blocks, which is very, very cool. See this part here. And you can explore with this, obviously. Let's try 25. Yep. So it helps a lot, you see here, more breakups. And this is the type of breakups that you want to add to the geometry. Okay, let's continue. I'm gonna add a point here. I'm gonna copy this, and we just have to be careful with the high res geometry, because it can be slow, as it needs to go in and generate new geometry, so it has to account for all of those, and this is quite a heavy mesh, and I wanted to show you guys how we can deal with that. Okay, so let's see this guy. Cool, maybe here too much. Let's say 10. Let's lower this 4. Something like that. Pardon me. Let's try 80. And I'm also going to go inside the Voronoi node and make sure that I give them correct names and correct and unique names, so we have the data correct at this point. Okay. So for this guy, let's copy this as well. Pardon me. And it's gonna take a few seconds for it to finish, probably a minute. Depends on how much it needs to go through each primitive and subdivide it, basically. And the higher the resolution you have, the more it's gonna take to do this processing. Now, obviously, it didn't take too long, which is great, so we don't have to pause the video. Cool. So I wanted to talk about the. Let me open the pad. Almost there. Okay. So I wanted to talk about the edge displacement thing, and most of the talks you see, most of the examples you see on the web or on forums and stuff like that, they only cover doing the edge displacement on the geometry. So you start with this. The idea is you start with this, and then you want to add details to this edge at render time. Now, the main problem with most of the solution is not adding the edge displacement. There is so many ways to do that, but the problem is restoring the texture information. And depending on how you did the edge displacement, you can restore the texture, the UV information, because what happens, we start with this, let's say we divide it into like that. We take this geometry and we upres this edge here. Now, these two blocks are now different. The UV has been distorted. So we need to restore that. And the way to do that, at least in Mantra, is you have the distorted geometry, and you provide the render with a copy of the original mesh that didn't distort, that doesn't have any distortion on it. And then you can shoot rays and basically capture the UV coordinate from that. This is with Mantra. Now, let's say you wanted to use Arnold. You cannot do this workflow. You have to write a custom shader. If we use Redshift, then it's a whole nother story. And then you've got V-Ray and Octane. There's all kinds of renders that is going to present challenges to do this. Now, the edge displacement itself is another whole story that requires a lot of complex processing in the shader, and I personally found that we spent so much time trying to solve this in the render while we can do it in the scene and just have heavy geometry that works with any rendering. You don't have to worry about this. And I've spent almost a year just doing research on and off on this topic, and I don't have a great solution for like that encompasses all the renders. And let's say you wanted to, for example, run a high-res sim of particles that needs to interact with the edge. You don't have this information only in the render. So when you send it to the render and you have a close-up shot, you have a straight line that you use to sim the particle collision, and then in the render you're going to get this. So the particles will be intersecting. And my solution is to do it in the scene. I'm going to show you a very, very simple, naive workflow for this. The first part of it is to add the edge details, and then the second part we will do later is to do the interior, custom interior, high-res interior surfaces. Because if we explode this now, let's see. Yeah, you can see the interior is very low res. Okay, so we need to find that idea, the workflow for doing that. Now, people are going to complain and say this is a high-res geometry that we started with. Well, this is my actual geometry. This is what I received, let's say, from the modeling department. So I have to work with that. I can, for example, if it's a low-res geometry like this, I can divide it here and add more polygons to describe, to be able to do these high-res edges. And it's actually not that bad to increase the geometry, and it doesn't, if you take the flat geometry and subdivide it, it doesn't take a lot of, it doesn't add a lot of overhead, because Bullet can simplify that as long as the silhouette does not change drastically. What adds the real increase to the polygon count is the interior surfaces that we have to create, and for that we're not going to be passing them to the render. So we're going to create two meshes, one that has the high-res details, the high-res fracture, high-res edges, and flat interiors, and then another one that has the same edge details but has a high-res interior. So we're going to have two copies of the mesh, and let me show you the naive way of doing this. So this Varna fracture is happening based on these points and on this geometry. Let's create a rest attribute. This is going to store the current position of the points into a rest attribute. We don't have to use, we don't have to use this node. We can use a wrangle node and say v at rest equal v at p, and that's basically the rest node. Almost there. Okay, cool. So what I'm gonna do is I'm gonna create a point VOP. I'm gonna dive inside. I'm gonna add noise to this mesh. Okay, let's change it to 3D noise. Let's expose these guys. Just like that. I'm trying to avoid having this kind of overlap, so I'm going to lower the amplitude a bit. Something like that. I don't want it to overlap basically or collapse on top of each other. Now with this geometry, I'm going to fracture this. I'm not going to fracture the original one. Now I'm going to fracture the post-deformed mesh. So it's going to take a couple of seconds. We'll wait for it. And then the idea is we stored that rest position. After the mesh gets fractured, we're going to restore the original position. And this is going to make sense in a second. So we copied the position and stored it in a rest attribute. I'm going to restore that. v at p equal v at rest. And this is a great feature of the Voronoi. It inherits the attributes from the geometry. And now look at that. Done. We have a perfect high-res edge details. And if we explode them now, we have very cool details. And we can go as high-res as we want with this. And as you saw, basically all we needed to do is do the noise here. And what's happening is we're fracturing this mesh as it is. So this point, instead of being fractured at this location, let's say, it's being fractured here, and then we move it back. And that will apply the distortion back onto the edges. Try it out. It will make a lot of sense. And so this is my workflow. This is what I would use for the sim. And then the next version that I will create is the exact same mesh. I'll just isolate the inside. So here, the Voronoi node creates two groups, by the way, one called inside and one called outside. And we can isolate the inside from the outside. So these are the interior surfaces. I would divide them. And this is a quick rundown of the workflow. I'll divide them like that. And the Voronoi node has a way to add surface details, but I don't like it. It's very, very slow. So we're going to create something that is much more solid. So this is the interior faces. And let's take a look. Yeah, this is the interior faces. And I'm going to add a noise to them. Just the same noise here. So it's distorted now. And I'm going to merge it back with the delete non-selected with the outer faces. And let's explode the view. Let's set a color node. And now we have high-res pieces with interior details. Now the edges obviously are messed up because this division, adding the interior details is not done correctly, so it's moving the edges. We're gonna fix that later. So this is it. This is what I'm gonna be using within the sim. And actually, let's delete all this. And let's create a null node. I'm going to turn off visualize colors, out RBD. I'm going to create a dot network, this RBD sim. As usual, bullet solver, RBD packed object, and we need to pack the data, gravity, ground. Do the merging. Now the merge is very, very important. The collision should always come first. Out RBD, let's go back up and use an assemble node to pack this. The name attribute is already set here, so I don't need that. I'm gonna just take on create packed primitives, and let's hit play. And it's working perfectly fine. Cool. So why the sim didn't slow down? Well, the reason for that is if we go to the RBD packed object and go under the bullet tab, the bullet data tab, you see here there's this geometry representation convex hulls. And if we tick on, we see bullet created an approximate geometry for these pieces. And as long as we don't change the geometry drastically, as long as we don't add tons of details, for example, the interior, if we added the interior details, it would mess this entire workflow. And independently from how much polygons we're giving to bullets, it's always generating these this collision. And as long as there's nothing weird with it, it's gonna work just fine. So let's turn on the display geometry. this is our workflow. Cool. Okay, let's continue, and we're going to set up the other piece, which is this guy. So let's do this same workflow as well with this and this. And let's see how it reacts to this. Obviously, if we push it a lot, it will generate issues within the mesh, so we have to be careful. See, for example, here caused an issue. So I'm going to go back and simply change the noise a bit so it doesn't cause these issues. I'm going to increase the pattern, lower this a bit. And I rushed this a bit. I combined all the pieces together so we don't have to deal with a lot of geometry, and it's not too complex. Cool. So I think pretty much there. We have some cool details. Obviously, we can increase the resolution of this so we can describe the edge details a bit better. Okay, now I'm going to combine this. I'm going to combine these two pieces together under the out RBD. You can send as many packed primitives together as you want, and same with the constraint. You can combine all the constraints. The only indication or the way to tell DOPs how to use them is using the data name. Okay, so let's see. It's still cooking. It's cooking this graph again. Let's give it a few seconds, and then I'm going to merge these two guys together. So merge here. Okay. And let's see. Actually, I don't have to pack them here even. Yeah, I'm going to combine all of this. I'm going to assemble them afterwards. Now see this name, this collision here, it's complaining about two attributes that are not, they exist here and they don't exist here, and vice versa. So we have to delete the CD attribute if we wanted to keep everything clean, but it's not a problem. Let's dive back in. Sometimes it doesn't refresh, so I just do a copy like that. And let's hit play. Cool, so everything is working and falling as expected. Now the back portion has been fractured, and I'm going to show you in the next video how to do the Voronoi, the wood fracturing, which we haven't learned yet. And then we're going to start adding forces and the constraint network. Thank you guys for watching, and see you in a bit.